Hello. Good morning. Thanks for coming. I'm obviously not Jennifer Bain, who's in the official program. She's unfortunately not able to come, so I will replace her today. My name is Jan Sültemeyer. I'm the Global Sustainability Leader for Avient. And I would like to present you today a little bit about additives and how they are affecting circular economy, specifically also recycling. Little spoiler ahead, they're not all bad, so they can be very helpful. So, let's start from the beginning. So who's Avient? Some of you might not yet know who we are. Actually, we're a new company with a long history. We are the combination of the legacy Polyone, who acquired the Clariant master batch business. So we are a leading supplier in the space of additive and color master batches, but also compounding in the area of specialty engineering materials. What? So somehow my slides are independent from my click here. Sorry. So what we do is actually very much focused on sustainability. So our journey is mainly in the 4 pillars, how we call them our 4 Ps, which is people, products, planet and performance, where we try to bring as sustainable solutions as possible to the market. Today, obviously, I will focus mainly on the product section, which will really highlight the additive products which we sell into the circular economy. When we come to circular economy, we have to say we are not really yet there. So what we are doing, I would say currently, is a recycling economy. So we are able to recycle materials maybe once or twice, but ultimately if the polymer sees the recycling stream too often, it will probably have to go to the waste, to the incineration, or in the best possible case, to the flower pot. So how can we change that? How can we really keep materials as long as possible in the cycle? So this is actually what we are working on with our recycling solutions. We also have other solutions in our portfolio which highlight different other aspects of sustainable plastics. We are also selling, for example, products which support biopolymers in the plastic industry, stabilizing biopolymers, make them fit for use, or also using biopolymers as carriers in our master batch solutions. Apart from that, we have lightweighting solutions which also help to reduce energy or use renewable energies. But as I said today, main focus is, of course, as we are on the PRSE today here, on recycling. Just as a quick overview of our portfolio of additive solutions which we are selling into the recycling market, I'd like to differentiate between design from and design for recycling. So what does that mean? Design from recycling is essentially, I start with an already recycled material, which might be already a little bit damaged, colored, pre-colored, a bit smelly, and you want to upgrade it into a version of a material that can be used in an as high as possible quality as you like. And here we have a whole range of different products which we are selling, starting from compatibilizers, really bringing mixed waste streams together to have a homogeneous polymer phase. We have solutions counteracting stress cracking. We have chain extender to repair broken polymer chains, especially in the PET area. We have processing aids, stabilizers, but also color solutions, really trying to understand what can I actually do with a pre-colored polymer and which color can I in the end achieve. This is all actually to upgrade an already existing PCR material and make it fit for use again. And on the other hand side, you have the design for recycling. And I like to compare these two with aspirin and vitamin for plastic. So the aspirin is for me more taking away the headache maybe from the converter because the quality is not so good and just need to have a quick cure, but it's not really curing the disease. It's not really making the recycling stream much better. It's just upgrading a material which you currently have. And on the vitamin side is how can I keep my polymer healthy and stable in the process, in the recycling, in the circular economy as long as possible. And that's designed for recycling. And here, for example, we have, again, stabilizers, which are proven to stabilize a polymer over many cycles without losing any efficiency and keeping the polymer properties, the oxidation induction time at a very high level. We also have a whole range of detectable colors. If you start with a black color, in recycling it's always bad because carbon black is inside, it's not sortable anymore. We have stable colors, so very stable toners for PET, for example. If you come from a blue water bottle and want to go into another blue water bottle without any yellowing and without any optical brightener inside, you need to have a very stable blue colorant which is not yellowing in the recycling process. Inkless printing is another story. So we know that inks and glues can give a very negative effect on the recycling stream. We propose laser marking as an alternative. It's one monocolored, however, you have no printing inks inside. It's just charring the surface of the polymer. And of course, recyclable barriers if you come to the packaging part. Why is that so important? Because we will go following the plastic, the PPWR, we will have more and more PCR in our waste stream, going up to almost 60% in 2040. So it's a long shot, but it's actually tomorrow. And that means we will accumulate more and more debris, more and more damaged polymer in the recycling stream, which will be very visible in the products which we are producing. So in the past, maybe we had like 10% PCR in a bottle. It doesn't really move the needle. It doesn't really change anything. You have 90% virgin, you don't have any effect. Nowadays, if we look at recycled water bottles, they're already a little bit grayish, which is fine. Consumers can live with that. But what about NIAS? What about mechanical properties? And the more and more you increase the PCR ratio in a packaging article, you will also increase the amount of recycled materials which has seen the loop once again and again. And that will mean you will have to work on it. Otherwise, the recycling stream will lose in quality very quickly. I dare say, if we would all products in the market packaging would move to 100% PCR, like some brand owners doing as a kind of a showcase, the quality of the European recycling stream would probably go down the drain very, very quickly. And that's what we want to work on with the additives to support actually a better circular economy. And this is only PET. Now, if we talk polyolefins, you can imagine it becomes even more difficult. So in Avient we said if we want to really do scientific research on the mechanical recycling process, we have to invest. And what we did, we invested into a unit which we call CycleWorks. It's not a bicycle repair shop, it's actually a small-scale recycling unit where we can recycle material in a 50 to 100 kilo scale. So we can really start making our own specimen, like films, chips, bottles. We can grind them to flakes. We can wash them under industrial conditions, scaled down. We have a small-scale Sorema washing equipment. We can go caustic soda, 80, 90 degrees, really put some stress on the polymer in the washing process, and then go through different extruder, mono screw, single screw, twin screw. We can apply high vacuum, really mimicking what recyclers can do, and then go back into the bottle. And then we do the wheel again and again and again and really see what happens to the polymer, how is it degrading, how can we stabilize it, what kind of additive actually supports, what kind of additive is actually hindering the process. So we are very flexible, very versatile in this unit. So it's really scientific investigation of the mechanical recycling process. Now, looking at the lifetime of a product in the circular economy, we usually start with the material selection. This is actually where we say, okay, we want to have let's say a water bottle made from PCR, and I want to have like 30 or 40% PCR included. So I need to pick my right material. So that's the first step. And the next step, you come to the preform production. In the preform production, you are trying to give the right color and also other mechanical properties, like try to reduce the smell. Then you go to the bottle blowing. And the blowing process for the converters is very important to have as less possible blowouts as possible. So high efficiency, fast moving lines without any blowouts. Then you go to the market. And in the market, basically, the packaging has a need, which is protecting the food, for example, which is inside. So you need to have the right protection systems from UV, from oxygen, and you also need to make sure that the products are food safe, so there's no NIAS, no migration. And then consumer uses the product and throws it into the bin, and then you come to the sorting. It needs to be sortable. As I already mentioned, dark colors are very difficult to sort. In the next stage, then you come to actually into the recycling process as such. And here I come with my aspirin again. So you need a little bit of aspirin to make the product fit for use for the next cycle. And in all these stations, you will need additives actually to support what you want to achieve. So let me go step by step through this process. So starting with the material selection. In the material selection part, it's basically about how much PCR do I want to introduce and what type of PCR do I have. In PET is probably rather simple because the quality, especially in Germany, for example, with the deposit return system, is rather high. If you go to polyolefin, it's much more difficult because you will have already a strong coloration of the material. What can I do with my color? How can I achieve my target color? I want to make a nice, or let's say, yellow shampoo bottle, and I start with a dark gray. Is that possible? So from Avient, we can actually help. We developed a so-called color prediction tool, which can compute and calculate which colors are feasible based on a gray starting material. Last year at the PRSE, we won the Innovation Award for this innovation for this tool, heavily used by now, and we had a very nice showcase with L'Oreal, who used it actually to color the red can shampoos. And that's a nice, it's not an additive, I have to admit, but it's a very nice tool, very versatile to understand how can we actually use a pre-colored material without any drawbacks for our final product aesthetics. But today I want to focus more on compatibilization, because especially in polyolefins, if you want to go for a PP application, polypropylene, you always have a mixed waste stream. Up to 10% PE is inside. And even though both are polyolefins, they're not really super compatible. If you look at the electron microscope, you will see there's different polymer phases. They're not really homogeneous. So what we did in collaboration with PreZero was trying to develop a new compatibilizer which is helping to compatibilize recycled waste streams PP and PE. And we found a very good formulation for this, which actually works great for the application. And the nice thing you can see in this chart on the side, and unfortunately resolution is not so high, so I'll explain. So you can increase the impact strength and ductility of the material. So it becomes softer and impact strength becomes higher. So you have a very rigid and stable product, which is drop safe, I would say. However, if you increase ductility, normally you would lose top load because it becomes softer. But this was something, so the stiffness and the mechanical strength we were able to keep constant. So it was really the perfect formulation at the end of the day to go in household goods. So it's not a packaging article. So this is a product which we call Cesar Unify, and Unify obviously is the unification of these two polymers in the sense of this additive. This year we are nominees for the Innovation Award here for tomorrow in PRSE. In the next stage we come to the preform molding, and as I said, you want to pick the right color. I explained already the color simulation tool, but another thing which is important when you come to the preform molding, especially in PET water bottles, in PET you often have the acetaldehyde as a byproduct in the PET, and it accumulates in a waste stream. So what you normally add for water bottles, not to have any nasty off taste, you add an acetaldehyde scavenger, AA scavenger, which chemistry normally is antranilamide, and that's a product which has been used for years. It works fine, but if it comes to recycling and multiple loops, it has certain drawbacks, because it tends to sublime. You can have deposits in your SSP, on your molding equipment, and therefore we developed a new product which we now also launched this year, which is the so-called color matrix anchor. And we call it anchor because it's a more bulky molecule. It's bigger, it's more heavy. It's not migrating so fast, it's not subliming. You can heat up to 300 degrees compared to the old version, our AAA, which is already at 250 degrees actually coming out of the product. So it's a very stable product, and it gives big advantages, especially if you talk about recycling PET. Now coming to the blowing part, as I said already, in the blowing of the bottle for the converters it's very important to have a high throughput and very good quality bottles. The The trick here, if you use rPET, is that the energy that the rPET is absorbing, the IR wavelengths, is not exactly the same than from standard PET. So you need more energy to heat up a recycled PET than a virgin PET. So we developed a Smart Heat RHC, which is a reheat additive system which you can add to the polymer, and actually this additive is absorbing the heat, transferring it to the recycled PET, and enabling a more homogeneous melt. And this very homogeneous melt, first of all, you can save 25% of energy, which equals also 25% of CO2 emission reduction. It's a very nice side effect. But this very homogeneous melt is also in the mold, forming a very homogeneous wall thickness throughout the entire bottle. So what we see actually, by using already very small amounts of this material, you can improve burst pressure and top load of the bottles by a few percent. So it's a really versatile product for PET bottle blowing. Then, as I said, product comes to the consumer, and here the packaging needs to protect the content. And protecting content means you need UV protection, you need light protection, and you need oxygen protection. And for all these, we again have additive solutions. We just got a certification for our Color Matrix Ultimate UV 390, which was approved by Recyclers to be recyclable in the PET stream. But we also have Lactra, which is a light blocking system with low content of titanium dioxide for dairy packaging. And of course, the Amosraw product range, which is an oxygen protection system, for example, for orange juices. Works well now also in the new version with recycled PET. Sorting. I mentioned already, black or dark products are difficult to sort. And if something is not sortable because the NRR system cannot detect which polymer is actually coming through the TOMRA sorting line or the Pelling sorting line, then you will not be able to recycle. So a non-sortable product is essentially not recyclable. And that's the reason why more and more brand owners are using dark colors not made from carbon black. And here we have a whole selection of on-color NRR detectable colors which we sell to the market. And we really see that the sales are picking up because mainly driven by the PPWR, all black and dark packaging will need to be switched to these kind of color systems, otherwise they will not be sortable, hence not recyclable, hence not being able to put on the shelf according to PPWR. So this is really something that is coming up and becoming very, very important. It is very important to say that I'm not only talking about black, because this is a typical, you have your, let's say your famous shower gel in black or the food tray in black, but also dark colors, dark blues, dark browns. They all contain a high amount of carbon black normally. So for all these, PET and polyolefin, we have a whole range of solutions which are fully NRR detectable and certified. Another topic, quickly, I mentioned it already, is laser marking here to have less contamination in the waste stream due to printing inks. We, again, as I said, would like to offer laser marking as an alternative. You can see also a few samples at our booth. So we have the booth B52, easy to remember, B52, where we have some exhibits for bottles which were laser marked, and also have some recycling example where we compare actually a film which was recycled based on laser marked and printed inks, and you see a big color difference in this film. Last stage, we come back to recycling. So the polymer comes back home, will be recycled, will be upgraded. And here I would like to focus on chain extenders for PET. So we have a range of our Color Matrix reprise chain extenders, which actually repair the damaged polymer chains. So you lift up again the intrinsic viscosity and the melt viscosity of the material and bring it back to a status which is very well usable in the next stage of recycling. We also offer here at that stage, again, these Optica toners, which are giving the stable color, which I already explained initially. So, as a conclusion, where we see ourselves on the market with our additives, but also with our color solution, is as a bridge or as a partner of the recyclers towards the converters and brand owners. So we might be able to work hand in hand with recyclers, especially when it comes to coloration, if it comes to mechanical property enhancement and to processability. And I think this industry advanced more and more. And depending on the recyclers, they are already pretty advanced, even in the coloration space. But we see more and more that this close industry collaboration becomes very important to bring the right material into the right application, fit for use for the end application, and then make sure that it can come back in the cycle time and time again to have a real circular economy. So with that, I would like to finish my presentation. Thank you very much for your attention, and very open for questions now on stage or also later on our booth. Thank you very much.